Hello students, today in this lecture we will solve some more examples based on support reactions. Let us discuss how the examples can be solved with the figure. See, this is the example in which determine the support reactions for the beam loaded as shown in figure. This type of question is given to you. Okay, we have to find out the support reaction. Must remember that in the previous lecture we have discussed about total 5 steps to solve the support reactions. Maybe the sequence of the support reactions or steps of the support reaction may shuffle. Step 4 first, step 3 next, then after step 2 first one. Okay, so you must remember those steps to solve the support reactions first. It is possible that steps can be shuffled by you, step can be shuffled by some other students also. So it doesn't matter. We want to solve support reaction, that is the main thing. Let us go to the example. Okay, what is given in the figure? In this figure, there is first we have to check which type of beam it is and what type of supports are there. In this figure, you can see this is a simply supported beam. Okay, this is a simply supported beam because two supports at the ends of the beams are given. Okay, two supports at the ends of the beam, not in between the beam. So this is known as simply supported beam. Okay, now concentrate on supports. This supports, as you can see in this figure, support A is a simple support and support E is a roller support. Okay, now concentrate on the loads. How many types of loads are given to you? First one is UDL 5 kilonewton per meter. Second one is this clockwise movement. Now this is the clockwise movement given to you. It is also known as couple. Unit kilonewton into meter. Here you can see in the UDL unit is 5 kilonewton per meter, while in the movement unit will be kilonewton into meter. This is kilonewton per meter. This is kilonewton into meter. What should be done with this moment? We will discuss it later. And the next one is point load. Its unit is kilonewton. So most of the things are clear from the units. When the UDL is given, unit will be kilonewton per meter. When the moment is given, unit will be kilonewton into meter. When the point load is given, unit is kilonewton only. Distances are given to you as shown in figure. Let us see the distances first. UDL is concentrated over the 3 meter span. Then after this movement is there, point load is at point D. What we have to find? Our target is to find reaction at support A means RA and reaction at support E means RE. Must remember that in this figure only and only vertical reactions are present. Why? Because there is no inclined force, there is no horizontal force acting on the beam. So when there is no inclined force or there is no horizontal force, then only vertical reactions are present. Therefore the reactions are named as RA and RE directly. R means reactions. If there are vertical and horizontal and inclined, all the reactions are present, then these names should be VA and VE. Vertical reaction at A and vertical reaction E must be there when there is an inclined or horizontal reaction is present. If only vertical reactions are present, then as per our method, step 2 and step 5 are cancelled. Only 1, 3 and 4th steps are remaining. Simplified figure you can imagine in your mind also. Here what happens? Unit UDL 5 kilonewton per meter is directly multiplied by 3 meter. So total load will be 5 into 3, 15 kilonewton. Then after it will become kilonewton. Per meter and into meter cancelled out. So UDL will be 5 into 3, 15 kilonewton only. This UDL as it is, this clockwise movement as it is. Now let us start the sum. As per our method, we have to take movement as per step number 3 at point A, means at left support at this point A. Taking movement at A, what happens now? Anti-clockwise movement is always equal to clockwise movement. Means we have to balance the movement. Sigma movement is equal to 0. Then and then beam can remain in the steady equilibrium position. Now in the anti-clockwise movement, you can see start from the opposite corner, means at this corner at point E. This reaction RE going upwards. So rotate it at point A because we want to take the movement at point A. So this reaction will go like this in anti-clockwise direction and will travel the distance of 2 meter, 1 meter, 2 meter, 3 meter. So total will be 3 plus 2, 5 plus 1, 6 plus 2, 8 meter. So anti-clockwise movement will be Re into 8. Okay, now next one. This point load is of 15 kilonewton but it is downward, so its movement will be clockwise and distance traveled will be 3 plus 2 plus 1, 6 meter in total. Must concentrate on the figure. Figure is most important thing in this type of numericals. So 15 into 6 will be clockwise movement. So 5 into 3, sorry, this is 15 point load into 6 distance. Now concentrate on this UDL. 5 into 3. 5 into 3 means 15 is the total load. Always remember that UDL, after solving UDL, it will act at the midpoint exactly like this as shown in the figure. So from the midpoint, this distance will be 1.5 meter. So 5 into 3 is the UDL, solution of UDL, and 1.5 will be its distance. So by doing the total in your calculator, this total sum will give you 117.5 answer. Divided by 8 will give you first reaction Re, which is equal to 14.68 kilonewton. Okay, so this is our first answer. First reaction Re is now available. Step 3 is completed now as per our method. Now as per step number 4, total vertically upward force is equal to total vertically downward forces. Now vertically upward forces are Ra and Re. So Ra plus Re will be left side actually. Ra plus Re will be left side of the equation actually. And downward forces are this 15 and this 5 into 3 15. So total downward forces will be 5 into 3 UDL and point load directly 15. One thing I have forgotten that this 5, see this in this calculation, this 5 is for the movement only, 5 kilonewton into meter. Remember that when you are taking this movement, clockwise movement 5, then it will be replaced over clockwise side and without distance, because in its units already meter is into meter is present. So with the help of 5, in this 5, no distance should be multiplied. Okay, directly you just replace 5 kilonewton into meter, the movement clockwise direction as it is. Now coming back to the calculation, Ra plus Re is equal to total vertical load. So Re will be right side and it will be minus. So Ra is always total vertical load minus Re means the first reaction which we have calculated. So it will be 15.32 kilonewton answer. So this is the answer of Ra and this is the answer of Re. So this is the particular method to find two support reactions. This sum is very easy because in this numerical there is no inclined forces are present. Let us go ahead and moving on to the next example. Okay, so this is the next example. Here it is also no horizontal or inclined forces are present. So same as example number 1. Now concentrate on the figure. This beam is overhanging beam. Why? The support is at point B and is at point C as shown in figure. But the beam is not ending at point B. It is overhanging up to point A. Okay, so this type of beam is known as overhanging beam and supports are two. First one is at B and second one is at C as shown in figure. So two support reactions are present, RB and RC we have to calculate. Okay, let us start now. What are the forces? First one is 2 kilonewton, that is point load. 4 kilonewton, that is also point load, and 2 kilonewton per meter is the UDL, which is expanding from this point to this point up to 4 meter length. So total load will be 2 into 4, 8 kilonewton. Okay, now let us start the simplification. As per our method, we always have to take movement at left support only. Okay, not left extreme point. Left support only, not left extreme point. Remember my words. Where is the left support? The left support is at point B. So we have to take the movement at point B only. Okay, starting from this support reaction, this is RC. This is RC going vertically up. Okay, so its movement will be like this. You just see in the figure carefully. It is in the anti-clockwise direction like this. So distance traveled will be 4 plus 2 plus 2, total 8 meter. So RC is the first force and distance will be 8. This is the first anti-clockwise movement. Now as this beam is horizontal and overhanging beam, this 2 kilonewton will be downwards like this. So it will also provide like this anti-clockwise movement at point B. See in the figure, anti-clockwise movement at point B. So it is also at a distance of 1 meter. It is also at a distance of 1 meter. So another anti-clockwise movement will be 2 into 1. 2 is the force, 1 is the distance. Okay, coming back to the clockwise position. First of all, this 4 kilonewton is the point load vertically down. So it will be like this clockwise direction. Distance will be 2 meter for this point load. So 4 is the point load and distance will be 2 meter. Okay, so this is the clockwise movement. Now for this UDL total load is 2 kilonewton per meter and total distance available is 4 meters. So total load will be 2 into 4, 8. So this is the solution of UDL 2 into 4. Now as I have told you, UDL is always acting at the midpoint. So from the midpoint, you have to calculate the distance up to point B. Okay, so it is 2 meter plus 2 meter plus 2 meter as shown in the figure. So total will be 6 meter. So total UDL will be 2 into 4 and from the center of the UDL up to point B, the distance will be 6 meter. Now simplify these things and you will get the RC 6.75 kilonewton. So that's it for first support reaction. Now as per our regular method, total load just minus RC means first reaction which we have calculated RC just minus this reaction from the total load. Now what is total load? So first one is 2 kilonewton point load, second one is 4 kilonewton point load and third one is 2 into 4 8 kilonewton UDL. Okay, so 2 is the point load, 4 is the point load and 2 into 4 is the UDL. From these three total loads just minus RC 6.75 which is over here. Okay, so total answer of RB will be 7.25 kilonewton. So this is our second reaction RB and this is our first reaction RC. So this is basically the numerical in which two support reactions we have to calculate. Let us go ahead and see some another variety. Okay, let's see some another example. The same method is over here. No horizontal, no inclined forces, only two vertical reactions are present. As you can see, the supports are at point A and are at point B, but this beam from both the sides overhanging. Okay, but the support, left support is present at point A, so we have to take the moment at point A. Okay, B is the roller support, but it doesn't matter in this case. What is the difference between simple and roller support and how it will affect, we will discuss in the next lecture. Now concentrate on the load. This is the UDL 8 kilonewton per meter. This is point load 20 kilonewton and this is 15 kilonewton another point load. This is 8 kilonewton per meter into 3 is the distance for UDL. So total load will be 24 kilonewton. Let us solve the example now. See, taking moment at A, as I have told you, A is the left support. So we have to take moment at point A. Anti-clockwise equal to clockwise always. Starting from the opposite support means from the RB. Now RB is going upwards like this, so it is in the anti-clockwise direction and distance up to point A will be 7 meter. So RB into 7 is the first anti-clockwise movement. Now as the beam is overhanging, coming on to this portion, this is the UDL which will be 8 into 3, 24. So this is the UDL 8 into 3. But this UDL is acting at the center and it is on the left side of support A, so it will move like this in the figure. It will be moved like this in anti-clockwise direction. From the center, distance up to point A will be 1.5 meter. So it is 1.5 meter distance. Coming on to the clockwise side, 15 kilonewton is the clockwise because it is moving downwards and the distance up to point A will be 4 plus 3 plus 2. So total will be 9. 15 into 9. It is the first clockwise movement. This is the second clockwise movement, 20 kilonewton load vertically down. Its distance up to point A will be 4 meter. So 20 into 4. Just solve all the things and you will get RB equal to 25.57 kilonewton. So this is the first reaction, RB 25.57 kilonewton. Now as per our regular method, we have to find RA. For that, just subtract the RB which we have found out from the total vertical load. Now total load means UDL, which is 24, 8 into 3, plus 20 plus 15. So 24 means 8 into 3 plus 20 plus 15. This is the total load. And what is RB? RB already we have calculated 25.57. So just subtract this and you will get the answer of RA 33.43 kilonewton, and here it is RB. So these are the two vertical reactions. So in today's lecture we have calculated three numericals, and each and every numericals based on vertical reactions only. So that's it for today's lecture. In the next lecture we will surely start some important examples in which UVL is also acting, means triangular load, and some inclined forces are also there. So see you in the next lecture. Thank you till then.